into bigger drops. I'm bringing word the coalesce, that one. Coalesce means combining. So there's a drop is there of radius r. Okay, let me take. I think let me do one thing. Smaller. It will combine and it will form a bigger drop. Tell me like what will happen? Will there be any energy released or strictly they are drop, smaller drop. I'll do one thing, smaller drops. Larger drop. Okay, let's calculate initial surface area. AI should be equal to how much? 2 into 4 pi r square. Will I agree? Final surface area 4 pi r square. This much is what we have. Now let's go for anything. Can you say about the overall mass of the thing? Mass should be considered, no? So initial mass should be equal to final mass. Nothing will happen to mass, no? What is initial mass? Density of liquid rho into 4 by 3 final mass rho into 4 by 3 pi r cube. So therefore, this will be 2 r cube equal to r. So r equal to 2 to the power of 1 by 3 into r. This will be the radius of that one. No, they'll coalesce. Then energy released or what we have to call. So let's calculate the initial energy. Initial energy should be equal to surface tension into AI. This will be 8 pi ST r square. Final energy is how much? ST into AF. So this should be equal to 4 pi ST into R square. We'll compare capital R will R square. So this will become how much? 2 to the power of okay, final energy, which will be greater, final or initial? Let me keep here. Now 4 pi ST, no? So let me adjust one 2 here, 2 to the power of 2 by 3 there, 1, 2 I'll adjust. Anybody? So how much it should be? 8 pi STR square, I'll write it as EI. So 2 to the power of 1 by 3, cube root of 2. So tell me like which energy will be more? Surface area increases or decreases? Anybody? Or else I think I should have done here only, no? No, surface area increases or decreases?
Sir, it is 2 power minus 1 by 3.
2 power of minus 1 by 3. Okay, this will become. No, what do you say? Anybody? Cube root of 2? Just tell me the value of cube root of 2, so that will be easy for us. Anybody with calculator? Cube root of 2. Okay, I'll do it.
Sir, 1.25.
1.26, sir.
1.26. Huh? What do you expect? 1 divided by 1.26.
0.79.
0.7.
0.79, sir.
Okay, now we have very good data. 0.79 EI. EF less than EI. Same thing happens. AF will be less than EI. Now, when two smaller drops coalesce to form bigger drop, what will happen to surface area? Decreases. You look at AF. AF will be less than AI. So very important data. See, nothing, just information. We have gathered it and we are going to conclude here. When two smaller drops coalesce to form bigger drops, surface area decreases, surface energy decreases. Tell me, like, where do that decrease in surface energy gone? Converted into heat released. Released as heat to where? To the atmosphere. So what is the conclusion I can make it? When two smaller drops this is a conclusion. When two smaller drops coalesce, surface area decreases, surface energy decreases, and hence heat is released. And better say energy is released. So how do you can say I have information here? Where do that surface energy gone? Converted into, it will be released as heat energy. And hence energy is released. Okay, fine. So this day one conclusion is what we are making here. And now similarly, if a bigger drop breaks up into smaller drop, I think the reverse should come, no? Let me take same diagram. There's a very important data which will help us a lot in coming numericals. So there's a very important data. I just brought through everything, diagrams, everything. Bigger drop breaks up into smaller drop. Just the same thing, just already we have information. Just will rearrange them. Tell me what will happen here. We are very sure what like AF will be, AI will be greater than from the previous data. So what is the conclusion? R is equal to R equal to 2 to the power of 1 by 3 R. Okay, there's a regarding radius, and I'll check it. So what I conclude here, AI will be greater than AF. And tell me what should happen this one. Surface energy, EI, initially surface tension into 4 pi R square. Final energy. Final energy. This should be equal to 2 into surface tension into 4 pi R square. If I check it, EF will be greater than AF will be AF will be greater than AI. EF will be greater than EI, surface energy. Tell me, like when bigger drop breaks up into smaller drop, what should happen? Energy will be released or absorbed? Energy will be absorbed. Because from where that extra surface energy should come? So EF greater than EI. So from where that extra surface energy has come on their own. See, external agent is not doing on its own. If a bigger drop breaks up into smaller drop, surface area increases. When bigger drop breaks up into smaller drops, what will happen? Surface area increases. Surface energy increases. Then what happens? Energy is absorbed by the system. What is the system? The liquid. So from where that energy should come? From the atmosphere. From the atmosphere, what happens? These drops what will take the energy. Okay, fine. So this is the some basic conclusion is what we should have this one. So the area. So one more way of defining surface tension. If you are able to calculate the surface area, work done per unit surface area, you can define surface tension of force per unit length. You can define surface tension. Like not only two drops, it can break up into n drops. It can, if the bigger drop can break up into n smaller drops. In that case, the n should be brought here. Instead of 2 open, n will come. Okay, after this, we'll go for the next condition. Now, some small element of thing that one. So